So just a reminder, this is number 4 in a series, and the key messages from the previous 3 weeks, I believe, were these. The first week we spent really on objectives, and I was trying to make the point that everything depends on the specific objectives that you set. All the rest of the design is determined by those, so it's important that we get those objectives right. And also that week, we talked about this business of what the right N is. And the reason we've often end up talking about large N trials is because when you think carefully, when you look at the objectives and try to work out what the right N is, very often it comes out to be something rather large. And so we end up with a large N trial. But it doesn't have to be large. In week 2, I described the key elements of the design and the need to think through what those are, review them, revise them until we have a viable sort of trial that we could implement. Week 3, we focused on measurement, deciding what to measure, making sure that those things are related to the objectives and that they're relevant to farmers and practical for measuring in a large N trial. So what I wanted to talk about today is indeed moving from planning to implementation. And it seems to me that for conventional trials, that's quite easy. We think through the design, and when we've got the design, well, we can just go and start the field activity. If you like, the method is you just do it. I mean, you know what to do. There's a plan, and it says measure out plots like this, and plant the seeds like that, and then start recording the data. You just get on and do it. Now, when we're talking about large N trials with farmers, it's not as simple as that. And the reason is that there are things we have to do to prepare the farmers that we're working with, or to prepare ourselves for working with farmers. And there are things we have to do because we're working with large numbers. We've got large N. And these are things which they just don't apply when you're doing more conventional trials. And that's what I want to talk about today. What are those extra things that we need to do because we're involving farmers in the research, or extra things we need to do because it's a large N trial that we're doing? So if you think about involving farmers, we have a lot of evidence that shows that the success of trials done with farmers and trials implemented by farmers depends to a very large extent on how well farmers understand it. And I think there are 3 general, if you like, levels of understanding that farmers need. Yeah? The first is one about the overall aim. What exactly is going on with this activity? Farmers are not used to doing trials. Farmers all over the world are used to having extension officers or some sort of NGO workers working with them and essentially telling them what to do. Telling them to do something, demonstrating, training, and saying, you know, go and do this. And what you're doing now is quite distinct from that. What you're doing is going to farmers and saying, we've got some good ideas here. We don't know exactly which one's right or exactly how it's going to work. Try it out or help us learn. You know, together, let's try and learn how these things work. That's not standard practice. And so understanding exactly how the activity is going to work and the aim of the activity is something you have to spend time with farmers explaining. Then they need to understand something of how the design works. And then they need to understand a lot of practical details, like who's going to do what, how much space is it going to take, you know, what's going to happen if they produce cowpeas in this trial. Whose cowpeas are they? Are they their cowpeas, or are they going to be your cowpeas? These are all detail. These are probably things that you're used to doing, but I think it's worth. I wanted to say these because I know many projects ignore these aspects of making sure farmers understand what's going on. In terms of understanding how the design works, I listed an awful lot of things here, and this might look very complicated for farmers, but I've seen projects that make an effort in explaining to farmers. Then they understand, and it's not hard. Probably the key things are things like this line here that says compare like with like. Okay, the idea that in an experiment to compare, for example, two varieties, we're going to make sure that the comparison is just between the varieties. And we're not going to put fertilizer on one and not on the other, or plant one early and the other one late, or plant one on good soil and one on poor soil. If we want to understand the difference between two varieties, then we need to make sure that it is the variety that's the difference between those two plots and not other things. Now, farmers understand that completely if you explain it. But don't assume that that's what farmers will do automatically if you don't explain it. Farmers can have good reasons for thinking about comparisons in different ways than that. So I'm not going to go through that list completely. But there are a number of things there that maybe we could simplify that list a little bit as to what it is farmers need to understand. But have a look at it later on and make sure that you have there's some activity whereby farmers are introduced to these ideas of what they're trying to do in an experiment and how the experiment works. Farmers also need some sort of training in the components of the experiment that they're responsible for. So, for example, if farmers are going to be laying out the trial, measuring the plot and planting it themselves, which is necessary when it's a large number of farmers involved, then they're going to need some sort of training. What does it look like? Maybe you need a demonstration. Maybe you need to lay out one experiment per village so that farmers can come and have a look at it and see what the plots look like. I don't know, but there's going to be some sort of training necessary for the things that they are responsible for. Secondly, they're going to need inputs, the seeds or anything else that you're providing as for part of the trial. And most of all, important of all of things, is farmers need timeliness. They need you to be on time with these things. When we see farmers' reactions to being involved in a trial, after a trial, you ask farmers, what was it like? What were the good things about being part of this trial? What was not good about being part of this trial? The most common complaint about researchers and working with researchers and doing trials with researchers is that the researchers are late. They're late in bringing the seeds, they're late in explaining what to do with them, they're late in coming to take the measurements in the field, etc. Farmers in most parts of the world know that timing is important for cropping. Good crops require things done on time. And they so often say researchers delay them. They would like to plant the cowpeas 2 weeks earlier than they brought the seeds. They would like to lay out the Auger trial, you know, a week earlier than the time when you came to show them how to do it. So being on time is really important, and that means you have to make sure that you've left enough lead up time for things like the training or things like getting the inputs together and delivering them to the farmers, that you've done all that sufficiently early that you're not going to be accused of delaying farmers in what they think is the best time to do field work. There's one more thing here which you at least need to be aware of and think carefully about. And it's this notion of prior informed consent. If we were researchers working in the USA or in many European countries, we would not be allowed to do this sort of work with farmers without each of the farmers giving informed consent. That means knowing exactly what their roles and rights and responsibilities are in a trial, and explicitly agreeing, actually often agreeing in writing to taking part. Right? If you had a grant from a US donor, you'd almost certainly have to do this. And if you were associated with a US or a European university, you would have to do this. Now in CCRP, we don't do this, but I think the principle is right. Okay, confirming that farmers know and understand what's involved in being part of this trial, that they don't feel under any pressure to take part, that they know that they can withdraw from the trial at any time if they want to without any negative consequences. This is important. So I think the getting every farmer to sign something saying I understand is not appropriate for most of our situations. But the principle of being confident that they do understand, that they don't feel pressurized, and that they are willingly, voluntarily agreeing to take part in a trial, and agreeing that you can take the data and use it, etc. It's important that you are confident in that. Partly, it's just sort of insurance. If somebody comes along and inspects your program, that you don't have anything to be ashamed of in terms of the way that you're working with farmers in this point. So I don't know if you've ever thought about this before, but if not, then you might want to even read up about how prior informed consent is sometimes given in other areas of research, and make sure that we're following the principle, even if we're not actually getting written consent from every farmer. So yeah, I've said there, let's aim to comply with the principle, but don't let it take over, or don't let it spoil our relationships with farmers and so on. We don't want work with farmers to become very, very bureaucratic. It will put people off. All right, the second area to talk about then is requirements for working with larger numbers of sites or larger numbers of farmers. And I see two main requirements here. The first is that those people who are involved in taking measurements need practice and training, whether those are field workers or or farmers. You can't expect people to be able to take measurements and record data well without having some training and some practice. Now, in conventional trials, if there's one technician collects all the data, that's very easy to do. The training is completely easy. If you've got, though, maybe a large number of officers in each village, or whoever might be responsible for the data collection, then organizing the training and practice and making sure that people understand what their responsibilities are is more of an undertaking. So you need to make sure it happens. And the second thing you need to pay attention to is having a data system in place. If you think about large N and Farmer Research Network trials, there are many differences to the way data is collected and handled compared to conventional experiments. So these are some of the ones I could think of. The fact that probably many people are involved in collecting data. It's not just one person. Data are likely to be collected at different times. So some things you collect at the beginning of the season, some at the end, some in the middle. You might have to collect data from farms, from people, from plots. If you're going to measure those context variables, some of those context variables we're talking about are social variables, which means interviewing people, not just going with a weighing balance and measuring the weight of grain in a field. But it means you have to know how to interview people, and you've got to have a way of recording data from interviews. So new measurement methods used. We talked about that last week. There might be a necessity to have things translated into different local languages. We need to be able to record qualitative observations and those unplanned observations in some systematic way. Recording those unplanned observations is not much use if they can't be, if there's no way to make sense of them later on. So we have a big project in Kenya, for example, where they were very good. The field technicians, of which there were maybe 30 involved, were good at making these observations of what was going on in farms, but they were only recorded in their field notebooks. So to use them as part of data analysis later on turned out to be really, really difficult because they weren't part of a planned data system. They were just there in field notebooks. I've already mentioned that photographs might be part of the record. Maybe data that's been collected in previous seasons is still needed. So, for example, some of the data about farmers you might have collected last season. You don't need to ask farmers again this season how big their farm is or how big their family is if you measured that last season. But you need to be able to relate the data you're collecting this season to what you collected last season. Now, all those things mean that handling the data is very much harder than in a more traditional sort of experiment. It means you need a data system. You don't just enter the data into Excel when you collect it and that's good enough. You need to think carefully about the way data are recorded, recording sheets or apps. If you're using something like ODK, the way data is going to be entered or how it's aggregated, how you're going to be checking the data, how you're going to be able to quickly get some summaries of the data that's being collected so that you can confirm things are going on well, how it's all going to be analyzed, how it's going to be used and fed back to farmers. These things don't happen without planning. So you do need to plan all of this. You do need to train the people involved. You do need to have them to practice to make sure it works. So if a village officer is now responsible for monitoring the trials, you better have those people practice that task of monitoring the trials before the real data starts, so that we make sure that they know what they're doing and they're able to do it well. And when you do that practice, almost certainly you'll find you need to refine or update the methods you'd thought of. So the final thing I wanted to talk about was the idea of learning to do better. Doing large trials with farmers isn't something you go from zero to everything in one shot. And I was really pleased that the Cowpea project said that they're learning they're doing something this season so that next season they can do a bigger trial with more farmers. And I know that Fumigaskier have been sort of building up their skill, if you like, in doing these trials. I so you're certainly learning how to do these sorts of trials better. I'd pick out three aspects to learning, which I think are important. One is piloting. That means before you start a particular activity, try it out. Try out the steps, making sure that things are realistic. So if you're going to have technicians visiting farmers and collecting data, let them try it out first to make sure that that scheme works. If you're going to have farmers recording some data of their own, see whether you can try that out in some way first to make sure it's practical. So piloting as practice, and when you see what happens when you practice, and then you make some adaptations and you learn and improve it, so that when you go live, you have real data collection going on, it's going to go as smoothly as possible. The second thing is monitoring what's happening during the season. Okay, that means making sure that you have a good process in place for seeing what's happening in the field, hearing reactions of farmers to what's happening in the field, and being able to respond to it. And by being able to respond, I mean make some adjustments. So, and interesting, one of our projects in Tanzania last season, they had an interesting example. They had set up a very nice monitoring system. They were working with large numbers of farmers, and what they had is a group leader in each village, and that group leader had a telephone, and the researcher would telephone each group leader once a week and just talk about what was happening. And at some point, the farmers started saying, "Hey, we're getting horrible problems with aphids on our cowpeas. Farmers want to spray them. Is that okay?" Right? So there was an interesting bit of monitoring. Spraying for aphids had not been part of the protocol. Nobody had thought about it. They did that monitoring during the season, and now the researchers could think about, was spraying going to upset the trial somehow, or is this a sensible thing to do? They could think that, they can have the discussion, and then advise those group leaders and advise farmers on whether spraying is a good idea or not a good idea, and make those adjustments to the design based on that monitoring that happened during the season. And then the third point is learning over seasons. I believe that Fumigaskia and Cowpea Squared project are indeed learning over seasons. They're not doing the same thing every season. I've seen some projects, though, that sort of seem to make the same mistake every season and have the same problems season after season. So what that means is, careful reflection on what's gone well at the end of the season, critiquing yourself and your performance, doing that reflection with farmers, making sure you're getting farmers' reactions on what's gone well and what's not gone well, so that in the next season, you can do a bit better. All right, so I've now got one slide here to summarize everything that we've talked about during these 4 weeks. And the way I summarize it is this. If you think about the way we do standard research designs and practices, they are built on principles of research, and they're built on statistical principles. So, the classical designs we like to use, like the randomized block designs, they're built on some ideas of research, some ideas of statistics, and you come up with those research designs. Now we're trying to shift to these right-end trials, which are larger trials involving farmers. And what I've tried to show is that when we're involving farmers, then there are some further principles that we need to build on. And these are principles of working with farmers, maybe captured by CCRP's FRN principles, Farmer Research Network principles. And they're also principles of statistics. And those things add to what we've done before to help come up with a more appropriate trial. And then when we think about working with larger N, then again, there are some principles which we have to think about. And these are principles to do with logistics, to do with data handling, as well as statistical principles that also contribute to the design. So the idea is we're not throwing away what you've always known about research design and what experiments look like, but we're taking those basics and then adding further things to come up with something which is more appropriate for working with farmers and large N trials. And that's the scheme I tried to put into each discussion each week, of starting with what we're used to doing and then thinking, what else do we need to add when we're involving farmers in more stages of the research, and what else do we need to add when we're moving to larger numbers of participants or sites. And that's all that I plan to say.